2 billion years ago, well before humans had created conventional nuclear power plants, 17 natural nuclear fission reactors operated in an area that is today known as Gabon in West Africa. This is a true story. The year was 1972. At a routine analysis of uranium ore in France, French physicist Francis Perrin came across something unusual. He found a dark piece of natural uranium ore that had been extracted from Oklo. At that time, Oklo was in a French colony. Perrin found that the material contained a lower proportion of uranium-235, so it seemed likely that the ore had undergone some sort of process of fission, as in uranium-235 isotopes had been split in a nuclear chain reaction. Some people actually argued that Oklo was proof that aliens, ancient aliens, had once arrived on Earth and left uranium tracks in the dust there. But once scientists looked closer, they found that lower percentages of uranium-235 in the rock were surrounded by dark patches, as if the rocks around them had been scorched. They asked, what could produce so much heat underground in a typically cold mine? For further testing, Perrin and his colleagues concluded that the uranium ore had been produced naturally and that this process had occurred over 2 billion years ago. How did they know that? At that time, Oklo was a mudflat of soft clay that contained some uranium minerals and was regularly flooded by rainwater. This water collected in pools which contained algae or pond scum. The algae would absorb the uranium water, which concentrated it, and when the algae died, that concentrated it even further, until it reached a critical mass, which is what's needed to start a nuclear chain reaction. For a nuclear reaction to take place and continue, a moderator is needed. In this case, it was water, which helped to slow the neutrons down. There was just enough uranium-235 to keep that reaction going. And this process of fission produces heat, which explains those scorched marks that the scientists found on the rocks. This kind of makes algae nature's nuclear engineer. When this critical reaction is controlled, it can produce energy for years. In the case of Oklo, the water supply wasn't steady, so the Oklo reactor would have started and stopped numerous times. Scientists think that Oklo operated for about 150,000 years and consumed 10,000 pounds of uranium before it eventually stopped. The average output of the Oklo reactors was pretty small, around 100 kilowatts, which could power maybe 1,000 light bulbs or a couple hundred computers. By comparison, human-made nuclear power plants usually produce over 1,000 kilowatts of power. Scientists think that there are almost certainly more examples of these reactors out there, we just haven't discovered the evidence. So next time someone tells you that solar and wind are the most natural forms of energy generation, tell them about Oklo.